In the previous videos, we've shown you how to connect your instruments to the Caliso Temps laboratory interface. Now what we're going to do is run through a test and have a look at the reference temperature stability and how the set points changed. So here is the data coming in from our instruments. There is the Super DAC with the 3 channels that we've selected to add to the data logger. The data is coming in from the temperature block, process variable and set point. And going to the data logger, we've made one small change, and that is we've made the block process variable the test reference temperature. Now that's quite common in industrial calibrations. So going back to the test setup, there are our 4 set points. We've made the offset tolerance and spread tolerance both 0.5 degrees Celsius. The spread tolerance shows the deviation from the average of each point, and the offset shows you the average value deviation from the actual set point value. We'll change the logging period. There's no point in being too quick because by and large temperature calibration is a relatively slow process. As a rule of thumb, always record at a rate that's slightly slower than the speed of your slowest instrument. So we're going to apply our reference corrections now if we need them. In this case we've elected not to apply any because the calibrations of the reference thermometer are good enough for the job. But you can apply the various corrections that you can see there should you need them. So we're starting our test and we're reminded to make sure everything's connected and that we're happy, and off we go. The first thing we do is select our data block name. That is the preamble that will be added to any file names that the software produces during the course of a test. And there we go. The first set point is now sent to the heat source and the logging process begins at the interval that you've specified. So we're now waiting for the first data to come in, and that'll be along in a few seconds time. There's the real-time data and it's showing the set point and reference value. No data's come in yet. Just look down the bottom, you see a row of tabs. That is each channel. So if you wanted to view each channel, just select the tab that you want to, and that will show you the data coming in for each of those channels. So the first value is in now, and as you can see it's calculated the average reference temperature and the average channel value, and it's applied the stability criterion to that particular point. So the next point will be along in a few minutes time, and again the average values will be calculated and the pass-fail criterion examined. We are going to wait for 10 readings to come in because that's what we selected, and we must have at least 10 readings matching the stability value before the test is ready to be moved on to the next set point. So a few minutes have elapsed and the data for our first set point is building up nicely. Just to remind you, what we're doing is we're looking at the last 10 readings recorded by the data logger and we're taking their average. That average must not deviate from the set point by the offset tolerance, and each value must be within the spread tolerance of the average. And there we are, that's how we specified that in the test run. The 10 values are for the pre-stability, then we're going to let the test run post that for a further three values. So the top line is now turned green because the previous 10 values were within the spread tolerance and the offset tolerance, which both say true, true. And now we've got to wait for 10 lines to become green, and that is the pre-stability criterion met. In other words, the reference temperature has been stable enough for long enough and it's close enough to the set point to make it an acceptable reading. Now the reason why we do the offset tolerance is because if you'd inadvertently left the reference temperature on the bench, it would be perfectly stable at room temperature, not the set point. So the values are building up now, just a couple more readings, and if the test remains stable, we'll then go to the post stability, and once that's achieved, what will happen is data will be written to the store files that we're creating. There's the first one going in, and once the third value is stable, the next set point will be written to the heat source, the dry block, and the whole process will resume again. So keep half an eye on the blue box in the bottom left hand corner. You'll see that go to 50 degrees C. We're now post stability for 2. Don't forget it needs to be 3. Keep an eye on that. In a few seconds the next point will come in. Hopefully, yes, there we are. The set points changed when we're off on the new set point value, and the stability criterion will now be working on 50 degrees C, and there we are. To conclude this section on the laboratory interface, we'll just take a quick look at some of the data files that the software produces during the course of a test. And we use the viewer in lab interface to do that. And we'll open the data files. The very important thing to remember is that each channel will record its own data file. So that means to say that when you use Builder, each file, it represents a channel, and it's that you're going to use to produce calculations and calibration certificates. There are the set points that we recorded for each of the channels, and the results summary shows the average values and the set points for each of the set points that were recorded. So just to reiterate again, one file per channel. Each file will contain the set point values and a summary of each of those tests. So that concludes this presentation on the laboratory interface. The next thing we're going to look at is the certificate builder.